Yes, we can hear you.
Hello, can you hear me?
Yes, can hear you.
Yes, we can.
Yes, we can hear you.
Good. I think we have quorum to get started. Now, who can remind us what we did last time? Yes, guys, what did we do last time? Hello? Anyone?
We did ordinary list. Ordinary lists, something of the sort.
Ordinary is something of the sort. Which is which? Which one is that? Yeah? Okay, now, I know I did the introduction to the linear regression model, where we focused more on one independent variable. Now, what we did for those who were in is that we were able, to do some analysis in Excel, whereby we are saying if one wanted to look at the time spent and how it influences the score, then we are saying it is easier for one to do that. Please mute your mic if you are not speaking. Mesha, Simio, mute your mic and the video. And can you guys confirm that you can see my Excel?
Yes, we can see it. I can't see it on my side.
How is that? Others, can you see?
Yes.
Yes.
You remember this example where we were estimating the beta and the alpha?
Yes.
Now, you remember what we said was that we are looking at the effect of time and how it affects. Please mute your mic. I can't keep on muting you guys. Trust.
Yes.
Can you be telling your people when they get into class they mute their mic?
Sure.
Because it's quite I can't keep on muting everyone. Yeah, so what I was saying is that from the class notes, we were able to come up with a regression or the model that we were able to estimate. And one of the key things we actually asked ourselves is why didn't we include the error term here? Anyone who remembers what we said? Why we did not include the error term? Or rather, let me refresh a bit. Our title was the effect of time spent on Econometrics 2 student. We came up with the hypothesis, both the null and alternative. And the question maybe I should ask is, from this model, or from these results that you have already gotten, can we say we reject null or we do not reject null? Someone? Do we reject or not reject null? Yes? Someone?
We do not.
We do not reject null. Someone else? Yeah, guys. Are you with me?
Yes.
Did you understand what I was asking? Did you get my question? Yeah.
May you pardon
Right.
once again?
I'm asking this. We came up with the title, objective, and hypothesis. Then we had data. So we did estimation of the betas. We got the betas, and then we found that our equation was 57. This was the equation. So these are our results, and I'm asking from these results, when we say we reject null or we don't?
We reject null.
That's the first opinion. Do we have a different opinion?
Yes, we reject null.
We reject the null hypothesis. That's... Any other opinion? Yes. Any other opinion?
We fail to reject the null hypothesis.
Do you have another opinion? Do you have another opinion? Now let me ask you, why would you say we reject the null? Or we do not reject the null? Why would you say that?
We reject null because the time spent. Because the time spent is equivalent to the mark someone gets in the econometrics.
How do you know that? I mean, which criteria? Which criteria did you use to check that?
Hello.
Yes.
I
We
don't
have too
see
many
the
people with
reason.
them.
I don't
We
see
have
the
too
reason
many people with them.
rejecting null hypothesis or alternative hypothesis.
Who is speaking?
I'm speaking.
I mean, who? I mean, I can't. I don't know your name. What's your name?
Joshua.
Oh, wait a minute, Joshua. So we have many other people whose mic are on, and that's why we can't hear properly. Yes, now continue. Joshua, you have muted yourself.
I'm still speaking.
Joshua, now you can speak.
I don't see the reason of either accepting or rejecting null hypothesis.
Why is it that you can't see the reason?
We need to test the significance of the coefficient first. Is when we either reject or accept the null hypothesis.
You guys, you need to give a clap to Joshua. I don't know how you clap here, but Joshua needs a clap. For those who are able to clap, please clap for Joshua. Good. Now, the reason is, now mute your mic. The reason is this. What you have just done is to estimate the coefficient, the beta naught and beta 1. But you don't know whether those coefficients are significant. Look at the way we had written the alternative. We said we want to check whether time spent in class has significant effect. So how do you know it has significant? This one significant is very vital. So how do you tell that a coefficient is significant or not? It means you have to do hypothesis. You have to do hypothesis testing. There is no way you can say this equation from this, whether beta 1 or beta 2, whether it's significant or not, until you do hypothesis testing. Until you do hypothesis. Now, you realize in most cases, in hypothesis testing, and especially when you are focusing on regression methods, we usually have three ways of testing hypothesis. One is t-test. So number one is you can use t-test to test for hypothesis. Two, you can use the p-value test for hypothesis. And three, you can use confidence interval. as a way to be able to tell whether a coefficient is significant or not. So these are some of the ways that we use to test hypotheses. So without much ado, and given that we know now we need to test our hypothesis, I want us to do one thing before we go to theory again. I remember, class rep, you need to confirm that I shared with you Stata 15. Did I share with you? In the class? Did I share with you Stata version 16, 15?
Yes.
No.
Some people are saying no, others are saying yes. It should be in your Google Classroom. So what I want us to do, if you allow, we do two things here. We do two things. One, we estimate this same regression, this same data, we estimate it in Stata. We run it in Stata, and in Stata we want to do a number of things. One, we want to confirm whether our coefficients that we got, A, B, are they the same as what Stata will get or will give us? Number two, we also need to confirm, or rather to see, are there other ways in which we can interpret our results, like the hypothesis testing, and Stata give us hypothesis testing. So with that, then we'll be able to proceed to now use the same data, and probably we add a few, another one or two variables in our data set, so that it becomes multiple linear. Because as of now, we have been dealing with simple linear. We have only one independent variable. Are the objectives for today clear?
Yes.
Good. So you allow me, then I'll save this data. I'll save this data. Fatima, I can see you are sleeping. Are you able to do analysis when you're sleeping? Fatima. So I want to save this data and let's call it sample data data. The reason I want to do that is that I want to remove these blank columns, the XY, the one we used for manual. Then I also want to remove the sum and the coefficients that we got. So let me. I also want to remove these other variables that we had computed. So this is our original data. We had the name of the student, we had the score that they got, and the time that they spent. Of course, for us, we know that time is our independent variable, and the score is our dependent variable. So I would like us to go to Stata. For those who are using Stata for the first time, please mute your mic if you're not speaking. Brenda. Class rep, are you in?
Yes.
Is it possible to tell these people to be muting their mic when they join in? Or I need to get those, huh?
Yeah, I've done so. I've told them.
Okay. So I'm saying that I was able to share with you Stata. So for those who have Stata, the version that I shared with you, you don't have to install it. And let me explain a bit. I shared with you a zipped version of Stata. Yeah? I shared with you a zipped version of Stata. So the first thing you do is you download it. You don't have to do that now. But going forward, you need to do it. So that next time we do the things together. So it's a zipped folder. So the first thing you do is to unzip it. And I want to believe that you guys know how to unzip folder. But we should not be getting into how to. So once you open the Stata 15, of course, yours may not have as many files as mine has. So you look for an application. There's a file which is an application called Stata SE64. Stata SE, this one. This one. And you can see it's an application. So if you just double click this, it will open. It will open. So you don't have to install. So I'll do a very quick run through Stata so that at least you catch up, because I'm not teaching Stata now. So when you open Stata, you get to have, you see you have several windows. One of it is this, the one I've put black here. This is like output window. This is where the output will be displayed when you do the analysis. Then on this other side, you have variables, and you can see when you roll the data into Stata, the variable names will come here. The variable name comes in here. And each of those variables, you can check its properties, including the name, the label, and the type, and the format. Under this section here, we are going. Then down here where we have the command, and where the cursor is active, is that here is where you can type command. If you know a command, often you can just type it, and Stata will execute. It is important to note that Stata is case sensitive. So all commands in Stata in small cases or in small caps. If you write them in a different way, then Stata will give you an error. On this side here, we have the review. And here is basically where when you type any command, it is stored here temporarily. It's temporary because the moment you close Stata, these commands will be lost. The ones that were saved here temporarily, you will not find them. I can show you later on how to save them. Then in Stata, you can design data to work it in two ways. One is that you can use the menu, which is quite rich, or you can use the command to type the commands. Use the command. So I'll take you very quickly through each of the menus. And the menu, of course, you have the normal open. Here we are saying you are opening the Stata file. Usually the extension for Stata is .dta. The way you have extension for document, DOC, or XLS. So for Stata is .dta. So if you have a file that is saved as .dta, what you are saying is that you can be able to, open it. Of course, you can view, you can do, or even save and save as. You can. Why is it so difficult for people to follow instructions, class rep? Class rep.
Yes.
Why is it so difficult for your people to follow instruction? Please, guys, can you ensure when someone is not speaking, you just mute your mic? Otherwise, you are really distracting. So under the file bit, what you are saying is that, which is very important, is that you have a way in which you can save all the commands that you execute, and later on you can use them. Or you can actually save all the steps that you are doing, and that's what we call the log. So you can instruct Stata to begin taking into logs all the things that you do. Okay? Importantly, down there we have import. Stata accepts datasets from other formats like Excel, CSV. Yeah, so I was saying that you can import data into Stata using from different formats. You can import data from Excel or even CSV files or even SPSS, many other formats that you can be able to bring data into Stata. What is very important is to let Stata know the type of data you are importing so that then it recognizes it accordingly. Again, you can also export data from Stata to other formats like Excel and so forth. Importantly is that Stata has huge data sets that one can use as example. So you find that wherever you get stuck with any command in Stata, you can always go to the manual for the Stata, and then you get some of the examples, and some of those examples have even the data that you can play around. The edit button, of course, it has quite a number of things like copying a picture and table and so forth. But importantly, it has a small tweak where we are calling the preferences, and you can change, like the way you can see my background color here is black. So I could change that, and I say I want to say studio. If I say apply, you can actually see that the background here has changed. So you can play around with some of those smaller things just to make you happy. Then under data, we have so many options that you can do under this menu for data. You can do data transformation. You can combine data sets. You can create practices. You can do an undo language or meta language. There are quite a number of things that you can do. Importantly, under graphics, you also have you can draw graphs in Stata. You can draw graphs, but it's also good to note that if you compare graphics from Stata as compared to other softwares, you may find other softwares probably give you better graphs. So sometimes we combine Stata and maybe Excel to draw graphs if you want to. In Excel. The mother of all is the statistics. Here you have different type of regression models. Remember when I was introducing to you, I said the choice of the estimation method depends on how the dependent variable is measured. That happened when you are defining the cardinal numbers, continuous numbers, and so forth. So therefore, what that means is that if your dependent variable is continuous, then you estimate a regression using OLS, ordinary least square. And then that means you can run linear regression models. And there are many. I can tell you there are many, even depending on the type of data that you have, whether you are using regression, whether you're using panel data, or even time series, or cross-section. We have models like what we call box Cox, errors in variables regression. Quite a number of models that one could run. Then again, also when the dependent variable is measured as binary, meaning you have two outcomes. For instance, I may want to investigate factors influencing uptake of health insurance, and my dependent variable being uptake of health insurance, and I measure it as, do you have health insurance? And the answer will be yes or no. So I have two options there. So I can estimate such a regression model, but then I have to estimate it using maximum likelihood method, which are binary outcome, or ordinal, or even categorical, and so many others. As you can see, there are quite a number of them. Importantly is that you are hearing that yeah, so importantly is that you are also hearing that in this country there is like people are surviving, yeah. So you can actually do a survival analysis. So we have models that talk about survival of different aspects. So you can do survival analysis. This actually, it's very important when it comes even to health. You may want to study how the survival of young children, maybe the survival of you guys, COVID, and so forth. So there are quite a number of methods that one could use. And of course, the window here gives you options to choose to select which window to be displayed. The windows that I've shown you here, if one is not appearing on your screen, just go to window and then you'll be able to select one of them. Again, you have the help file here. The help is quite detailed. So you have a complete detailed PDF manual with all the commands and even some data sets, as I mentioned to you, showing you Yes? Any question? Good. So if there is none, then we ask ourselves, our data, which is in Excel, we want to put it in Stata. And the first thing we need to realize or to must remember is that the first row in Excel contains variable names. It does not contain data. It contains variable names. So we must tell Stata that our data, the first row, contains variable names. That is very important. So once you open our Stata, we can go to File, Import. Guys, tell me, what type of data are we importing?
Excel.
We are importing. We are importing the spreadsheet. So we say import Excel spreadsheet. I choose where I've saved that data set. Yeah, so I need to choose where I have saved it. I called it sample data Stata. Then you can see here it's asking me, should I import the first row as variable names? Remember in our Excel, the first row contains variable name. So we tell Stata import the first row as variable name. That's very important. Then we say, okay. Guys, tell me what has happened. What can you see here? What are the changes? Perfect, perfect. So you can see now we do have variables, and you can see them here. And from there, you can see there is a command that has been executed, and we are saying we are importing data from Excel and so forth. Then from there, you can also see there is a temporary command that has been saved here. Can you see it easily?
Yes.
Good. So if I happen to cross data, for instance, like the way I've just done, I've just crossed it, and I open it again, then I import. I import the same data, choose the first variable like that. No, before even I import, can you see there are no commands here under review? There are no commands. The way I was telling you that under the review here, the commands are only temporarily saved. The moment you close data, the commands will be gone. So it's important to note. So having done that and having seen our variables that have come into Stata, we can just interrogate them. And interrogating them, we can just look at data. We go to data editor. And under data editor, we have two options. Either we can view our data under data editor edit, meaning it gives us the opportunity to edit the values in that data set, or browse, which is read-only. So for browse, you can only see it. So let's go with browse. And you can see our data now. Can someone tell us what you can see? And what are some of the things you think through? Yeah, someone tell us. What can you see? Bernard, keep Korea, are you speaking? Are you telling us what you can see?
Okay, we have variables, the 10 variables we had in Excel.
Did you say 10 variables?
Yeah, we have under scores and under time spent.
Okay, that's a good observation. Actually, let me ask you guys, how many variables do we have here? From this data, how many variables do we have?
20.
20.
Two.
Two. Which one and which one?
Score
Which
and
one are
times.
Someone else? Which one and which one? Yes. Yes. There are 4 variables. Guys, a variable is something that has values changing. So like now, SON, serial number, is taking different values. Student name is taking different values. Score is taking different values. So we can say that score is a variable. Variable from the word vary, it varies. Then time spent is another variable. So we have actually 4 variables. And we have how many observations? How many observations do we have per variable?
10.
10. Good.
10.
You said 9? Did someone say 9? Yeah, so there are 10. There are 10 observations. And you can add 11 observations, like that. But guys, I'm asking, why is it that some data here is red, the other one is black? Why is that so?
Red means it is a string variable, while black means it is a numerical variable.
Okay. Very good. So red means it's a string. String is like a sentence. You can see students' name actually contains letters. They are sentences. So we don't have numerical in the other way. So without much ado and without really going deeper into so many things in Stata that you can do with, I think what we do is to be able to run this particular regression model and see whether we get the same coefficients as we got in Excel. So how do we do that? We go to statistics. Now, guys, let me ask you, is our dependent variable categorical, numeric, or continuous? Yeah? Guys? Are you there?
Yes.
Yes.
Is our dependent variable continuous, binary, or categorical?
Continuous.
Continuous. Good. So what type of regression are you? Suggestion?
Linear.
Say it in full. Say it in full. Hey guys, you know it. You know it. Which one? Hey, ORS, ordinary least square. That's what we said we use. So we go to statistics, linear models, and we are doing linear regression. We go to statistics, linear models, linear regression. We click on that. What did we say is our dependent variable?
Score.
And the dependent variable is time spent. Remember, this is a simple linear, so we have only one independent variable. We can say, okay, there we go. We get our results there. Now, guys, can someone try to interpret anything here from these results? Anything? I want to hear. Anything? Guys, are you there? I mean, it doesn't have to be correct. Just try. Guys, are you there?
Yes.
Yeah, from these results, anything you can relate or you can remember. And I'm saying it doesn't have to be correct. Just say
The constant 57.07 is the intercept.
So we have the constant, which is 57. What else? Hey, guys, are you seeing this for the first time? Hello?
The negative 0.5615 is the slope.
The slope. Is the slope. Are those coefficients the same as we got in our Excel? Who remembers what we got? Yeah, we have 57, then negative 0.6. Are they the same? Yeah, you can round off this to 0.6. Yeah. So you can actually see theta has given us the same coefficients we gotten when we used manual way of estimation. And basically what you are saying is that the formulas that you did last time, the betas, the formula for beta naught and beta 1, are already programmed in theta. So theta is actually in the background using the same. I know most of you is that you don't want to speak. I want to believe that most of you have come across R squared. Have you?
Yes.
What was R squared?
The degrees of freedom are 9.
The error.
What was R squared?
Covariance.
Huh? Which one?
The degrees of freedom are 9.
R squared was the goodness of it.
Goodness of it. And how did you guys interpret R? Hey guys, I think this is something you have already done, haven't you?
By using the standard error.
The R squared. We are still on the R squared. Okay, let me rephrase. What is R squared? What is R squared? Guys, what is
Goodness of it.
okay. Guys, are you coming across this for the first time? Huh?
Yes.
Yes.
You're coming across the word R squared for the first time.
No.
No.
So what is it? What does it measure?
It has the
Goodness of it.
Good. Measures the goodness of it. And the next question I'm asking about the R squared is, how do you know if you have different values of R squared? How do you know the one that shows is a good fit? Hey, guys, you had a threshold of 0.5. If
One
R squared
that's
is
closer
equal to
to 1 than
you
0.
you said that R squared ranges from 0 to 1. And if it is 0.5 or greater, you are saying that is a good. So now, based on the result we have, would you say that this is a good fit or is a poor fit? Based on the R square, the result from R square.
We
Guys,
say
I've already. Uh-huh.
if it is closer to the negative, the better the goodness of fit.
If it's closer to the negative.
Yes. The better the goodness of fit.
Irene, I like your courage for trying. I just said R squared ranges between 0 and 1. So you can never have R squared be negative.
Hello?
Yes, Joshua.
If R squared is closer to 1, then it's a perfect fit.
Joshua, a follow-up question about how close is close? How close is close?
Above 0.5.
Yeah, actually, we say 0.5 or above. It's a good. It's a good fit. Allow I'm asking a simple question based on the data that we have. Would you say that our data fits our model well? Is it a good fit or is it a poor fit?
It's a poor fit.
It's a poor fit.
Yes.
Why is it a poor fit?
It's closer to 0 than 1.
Just say, use the cutoff. The threshold is 0.5 or 50%. If R square is equals to 50% or above, it's a good fit. If it is below 50%, it's a poor fit.
It's a
Yeah?
poor. So
It
it
is
a good fit. It is a
It
good
is a
fit.
good fit.
Yes, because it is above 0.5.
Irene, what is the value of R square that we have?
0.0632.
Irene, did you check those values properly? Remember, we are comparing with
Mine was
0.5.
0.6. That's why.
Yours was 0.6. No, let's work with what I've projected here to avoid confusion. Huh?
Okay.
So the R square that we have shown here, would you say it's a good fit?
Then it's a poor fit.
Irina, can you mute your mic?
You know how much? 100. Take it.
Yeah, so guys, I'm asking this. From our results, it's is R squared a poor fit or a good fit?
A poor fit because it's less than 5.
It's a poor fit because?
It is less than 0.5.
Good. That's simple. So now, please note this, that R squared is used as a measure of goodness of fit. In other words, is the line of best fit passing through as many points as possible. That's what we are asking. Then we have this other one here, F, the F test. Who remembers what F test measures? What does F test measure? Guys, F, what does it measure?
Analysis of variance.
Analysis of variance. Remember, we are in the regression. Huh? And I want to say that you need always to note that analysis of variance depends on whether you are dealing with regression output or not. Huh? So basically, let me just summarize. R square measures goodness of fit. What we are saying, it measures the goodness of fit. We are saying it has a threshold of 0.5. So if it is greater or equal to 0.5, then it means we have a good fit. Now, F-test in a regression is a measure of joint significance. Measure of joint significance. It is a measure of joint significance. In other words, you're asking yourself, do all independent variables jointly together, basically, jointly, do they jointly affect the dependent variable? That's what you're asking. So you find F has a null hypothesis of there is no joint significance, and it has an alternative hypothesis of there is joint significance. In other words, all the dependent variables jointly influence the dependent variable. There is joint significance. So those are the options that we have for F-test. And guys, I want to be very keen on what I'm doing here, because when you go to the theory, you realize it becomes easier to understand the theory if you have already understood the practice. So what we are saying, therefore, is that this F is testing whether jointly the independent variables influence the dependent variable. And we'll be looking at whether it is significant or not. Now, for those who remember very well, the analysis of variance, as someone had mentioned, the analysis of variance, you had what we are calling TSS. Who can tell us what was TSS? What was TSS?
Total sum of squares.
Yeah, total sum of squares was equal to explained sum of square plus what? Residue sum of?
Residue squares.
Residue sum of square. Total sum of square is equals to explained sum of square plus residue sum of square. For those who are new, is that this, of course, you're looking at the y, and here you're looking at the independent variables, and here you're looking at the error term. So therefore, when we come in here, and this is good you note in Stata, the source or the model here, the source, one of it being the model, this is the ESS, this is explained sum of square, and SS means sum of square. So the sum of square, the value of sum of square is this one. The value of explained sum of square is 609 points. There's 1 degree of freedom, and its mean sum of square is this one, because mean sum of square is SS divided by degrees of freedom. So 609 divided by 1, you get 609. Then we have residue sum of square, which is 9037. There's 8 degrees of freedom. Once you divide, you get 1129. And of course, then you have the total sum of square. Remember, guys, that the total sum of square is explained sum of square plus residue sum of square. So if you add these two values, these ones, they should give you total sum of square. Then you have the degrees of freedom, and then of course you have the mean total sum of square. So the reason why you usually have this analysis of variance is because this analysis of variance gives you two critical things. One, it gives you the R squared, and also it gives you the F. It gives you the R squared and it gives you the F. And you see that shortly when we discuss that in theory. So please note that this analysis of variance is very critical because it gives you those two. Now we had adjusted R squared. So what usually happens is that as you keep on increasing independent variables in the regression, the R square always tends to rise. So as you increase, even if they are irrelevant variables, you always find R squares is going up. So to penalize or to adjust for that effect of just adding variables and R squared going up, we now use adjusted R squared. Again, I'll also show you the formula shortly. Then you have the root mean sum of square. Mean sum of square here means this is the error sum of square. Yeah. So when you get its square root, then you get the root mean square. Again, of course, without wasting much ado, we have the coefficients that we already know how to estimate. We have the standard error of each coefficient. Like now, this is the standard error of beta 1, the standard error of beta naught. Then we have the t-value, we have the p, and we have the confidence. So I want to quickly take you through this bit of hypothesis testing, and I want to take you through each of these tests. And we start with t-test. T-test. So in t-test, and I want to believe that you guys remember this, you have done this previously, is that you get t calculated and you compare it with t critical. And then you're able to make a decision of saying whether a variable or a coefficient is significant or not. So how do you calculate t critical? T critical, for instance, if you're calculating for beta naught, it will be the coefficient itself, beta naught, divided by the standard error of that coefficient, beta naught. So here, if you have to look at the t calculated for beta naught, so let's call it here beta naught, t calculated for beta naught, you realize that you have beta naught is constant. So you have the coefficient, 57 point something. It will be equal to 57 divided by the standard error of that coefficient, which is this. Which is that. Someone being getting us for that? You can do it in just one decimal place. You don't have to do so many decimal places. Then you can go ahead and calculate t calculated for beta 1. It will be the coefficient beta 1 and divided by its standard error. Again, you get the coefficient divided by its standard error. Its standard error. So someone give us an answer to this? Is the answer? I mean, you can round off this to one decimal place, make your life easy. Hmm, 76. Yeah, what is the answer? Guys, I'm waiting. This is quick. That should be
3.17.
3.1705.
3.17.
Yes, 05.
Now let's limit to two decimal places. The other one is?
Okay.
The other one is?
Negative 0.74.
Negative like that?
Yeah. Yeah.
Guys, are you getting the same thing?
Yes.
Yes.
Now, for interpretation, so we want to say if t calc is greater or equal to t critical. Now, remember the t critical, this is the t that you get from the t distribution table. And I'll be giving you the rule of thumb shortly for the t critical. So if t calc is greater or equal to t critical, then we are saying, then reject null. Reject null, or in other words, our results are significant. Our results are significant. That's what we are saying. The reverse is true. So if T critical, if T calculated is less than T critical, then do not reject null. And in short, our results are insignificant. Guys, have you understood up to that point?
Yes. Yes.
So if T calculated is greater than T critical, then reject. If not, not. Now let's go to the result. Actually here. Now before we get there, the rule of thumb, usually rule of thumb, these are the things that we commonly use without going to the T distribution table. We usually say that from the rule of thumb, T critical, we usually measure it as equal to plus or minus or plus 1.96. You must have come across this 1.96, which is when you draw a bell-shaped distribution, you have two tails. One will be on 1.96, the other one will be on positive 1.96, and the other one will be negative 1.9. So that's what we use as a rule of thumb for T critical. So you compare now the T critical with that. So guys, please, can you tell me, for beta node, are we rejecting null or not? For beta node. For beta node, are we rejecting null or not, and why?
Reject null.
Rejecting. Because it is more than 1.96.
Is that one person? Yeah.
It is significant. It is significant because it is more than 1.96.
One person.
We reject now.
Why are you rejecting null?
Because
Can we have one person?
we reject now. Reject null because 3.17 is greater than 1.96.
No? Now, one thing I forgot to tell you guys is that when you are comparing this, always compare with the absolute value. Absolute. What do you mean by absolute? Guys?
Without the sign.
We ignore the sign, is it? Both are in absolute. Please note that. In both, we are ignoring the sign. Do not look at the sign. For the T, just focus on the value. So we are saying we reject null because the coefficient, the T calculated for beta naught is 3.17, and we are comparing it with 1.96. So 3.17 is greater than 1.96. Therefore, we reject null. What about the beta one? Do we reject null or we don't?
We don't.
Do not reject null.
We do not reject null.
Why? Please don't tell me.
We don't reject null. Ouch.
I'm asking why.
Because the t calculated is less than the absolute value of the t critical value.
What is the t calculated value?
Yes.
What is the t calculated value? What is the value for t calculated?
0.74.
0.74.
Good. Good. Do we have anyone who has not understood how to interpret results using the t calculated or t test? So if there is none, we can go to p-value. Now for the p-value, I'll take you back to the number line that you did in secondary school. Take you to the number line. And the p-value actually means probability value. Probability value, probability. So probability, we always know that probability ranges between 0 and 1. So the values for the p-value will always be between 0 and 1. That's for sure. They always be between 0 and 1. They always be between 0 and 1. I want to draw a number line here. And I put here 0.05. So how many confidence intervals do we have? How many conventional confidence intervals do you have, guys? How many?
3.
Which one and which one?
%, 95, and 99.
Good. 90%, 95, and 90. Okay. Anyone who does not remember those confidence levels? Anyone? Okay, good. Now, confidence interval means you are, for instance, if you talk about 99% confidence, it means you are 99% confidence. Hello? Hello?
Yes. Hello.
I think I lost you and I keep on asking whether you are with me. So up to what level have I reached? Hello, can you hear me?
Yes, we lost
Yes,
you.
we can hear you.
We lost you by your
I lost you when I were doing what?
The 3 confidence levels.
3 confidence intervals.
You're explaining on the confidence levels.
Okay. So I was saying this.
You're explaining on the confidence levels.
Okay, so let's listen up now. And I hope you can hear me. So what we are saying is this. We have 3 conventional levels of significance. We talk about 99% confidence. We talk about 95 and then 90. We also know that when you say you are 99%, it means you have a margin of error.
You're breaking.
Can you hear me now?
Yes.
Yes.
I'm saying conventionally, we have 3 levels of confidence. We have 99, 95, and 90. So when someone says you are 99% confident, what is the margin of error?
0.01.
0.01 or 1%. Then the same case when you talk about 95 is 90. So those margin of error, 1%, 1% is 0.0. 5% is 0.05. Those are actually what I've plotted here. Okay? So as a rule of thumb, we usually use 0.05 for interpretation, especially we use 0.05 as a rule of thumb. So we say if the p-value is less than 0.05 or equal to 0.05, then we are saying you reject null. And our conclusion is that that result is significant. Other than that, we are saying do not reject null, the result is insignificant. And that's the small number I was putting in here. And I want to believe that you guys have been able to. Have you been able to see it?
Yes.
Good. So if that's the case, then our threshold is 0.05. We are comparing any value of p-value with 0.05. So if we come to our results again here, for time spent, which is our coefficient beta 1, we have a p-value of 0.484. So guys, tell me, interpret, is that significant or not, and why? Is that significant or not, and why?
No, it's not. We reject the null significance because it's less than 0. Oh, it's above 0.05, so we reject the null. We do not reject null significance. Sorry, it's less than. It's
Hello? Hello?
Yes, we can hear you now.
We lost you.
Back now.
Okay. So I was asking, can you interpret this p-value? Can you hear me now?
Yes, we can hear you.
Yeah, so can someone interpret the p-value for time spent? Someone to interpret?
we do not reject the null significance because 0.4 is greater than 0.05.
Guys, do you agree with her?
Yes.
Yes.
Yes, we agree.
Yes.
Good. What about the coefficient constant? interpret the p-value using the p-value? Interpret using the p-value? Hello guys, interpret.
We reject the null hypothesis.
We reject the null hypothesis. Why? Why are we rejecting the null hypothesis?
The p-value is less than 0.05. 0.05.
Yes, yes, it is. Good. So the other one, so that we wind up, is the confidence interval. Yeah, the other one is the confidence interval. Confidence interval. Now, if you remember from your basics, is that we usually have lower and upper bound. We have lower limit, which is this, and the upper bound limit. So we have two levels of confidence interval, the lower and the upper bound. So we usually say if zero is within the lower and upper bound, then what we say, reject, do not reject null, not reject null. So what you're saying is that if you are to look at where the lower bound is starting, all the way to where the upper bound is, and you find that zero is included there, if zero is within that bound or within that range, then do not reject null. Now let's look at it. Here, for time spent, is zero included within this bound?
Yes.
Is included, right?
Yeah.
So our conclusion is that we do not reject null. This other one is zero included?
No.
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 So we reject.
What do we do?
Reject null.
We reject.
Now, guys, I want to ask you one thing. Have you seen that whether you're interpreting your results using T, P, or confidence interval, the conclusion is the same?
Yes.
Yeah, the
Yes.
conclusion is always the same. But in analysis and even going forward, we usually use p-value for interpretation. So you really need to understand the p-value and how to interpret it, because that's what you use for interpretation. An example here is that we have F-test, which is a test of joint significance. It has its p-value. The one you're seeing probe here is the probability. And by the way, this p-value is the probability of committing type 1 error or type 2 error. It has its own way, it has its own formula for calculating, which is a bit wrong. We really don't get into it, but it's good we understand how it works. So you see here we have the F-test. And by the way, I can tell you also, we have different test statistics. You need to understand that. In statistics, we have different test statistics. What I mean by that, for instance, we just talked about having a t-test. And this t-test is from the regression line. You have seen how to interpret it. We have other t-tests for comparing means only. Those are test statistics. We have f-test, not from the regression, but the normal other f-test. We have chi-square test. We have word test. There are many tests. And I can tell you, most of those tests going forward, you find you test their significance just by using the probability value. In other words, you don't go to F distribution table or to the T distribution table. As you have seen here, we have not done that. To look for the values of F distribution, F in the F distribution table, or values of T from the T distribution table. So guys, I want you to interpret for me the F from this equation. We have the F, we have its p-value. Is the F test significant or not? Guys, if the F significant or not?
Insignificant.
Yeah, why? Why is it insignificant? Why?
It is more than 0.05.
Guys, do you agree with her?
It's less than.
It is?
Less than 0.05.
It is less than 0.05.
No, more, sorry.
So do you guys agree with her? I couldn't capture her name.
Yes.
Yes. We are saying is that we are what? We are rejecting the null. Now, the question is, what was null for this F? I think I already told you. I told you what is the null of this particular F. There is no significance. There is no joint significance. So in fact, it's only that the statement just to give us this F test. But usually it may not have much meaning. In this case, because you have only one independent variable. If we have more than one independent variable, then it will have huge implications. But for now, it's really not here. Not. So guys, so far, do you have any other questions?
Excuse me, sir.
Go ahead. Yes, please go ahead.
Could you please show us how to calculate, maybe not using the software, but how we calculate the p-value, the calculated one, without the software?
That's yeah. I had mentioned that we don't have to go that way because the formula is quite wrong. And since this is just probability, it's easier to understand. And you will even know, no one will ever test you on how to calculate the p probability value manually. Usually, is either the value to be given for you to interpret, but it cuts across. But in the textbook, for further reference, in the textbook that I shared, I think in appendix, the first appendix or second appendix, you'll be able to see the calculation. All right. Good. Any other question, comment?
Excuse me, sir.
Yes, please.
Could you please present again your Word document?
This one.
Yeah.
Google Classroom.
Teremka chini. The
Even
other way.
hivi
Yeah, hivyo.
Where up to here?
Ya mwisho.
Oh, this one.
Up. Yeah, that one.
Okay. I will be sharing these classmates.
Okay, thank you.
Thank you.
Any other question, guys?
Excuse me, sir.
Yes.
Kindly pardon on how we interpret the F test. F.
The F test, we say, is a test of joint significance. It measures whether all the independent variables jointly affect the dependent variable. So the null is there is no joint significance. Alternatives, there is joint significance. Then we have said use the t value, and you interpret now the p the normal way we have just shown you on how to interpret. Is that clear? Was it Moreidi or who was that?
But in the software we had been given an F value. So, and tukimalizia we we say that it's insignificant because it's greater than 0.5.
Now, remember, for us to evaluate the significance value, we are not looking at the value of F. We are looking at the value of the P. This is like our P calculated. P value calculated is what we are comparing with the P critical. And our P critical is 0.05. So we are asking ourselves, is this greater or equal or less than 0.05? We have seen it is greater. So if it is greater, we are saying we reject the null. But what is the null? And this is what I'm just telling you. The null, did we say we reject or we don't reject? I think do not reject. Yes, do not reject null. And we are saying the null here is there is no joint significance. Is that clear?
Yes, thank you.
Yes.
Any other question?
Excuse me, sir.
Yes.
There was a point talking about confidence, no coefficient after the p value hapo chini.
Yeah.
Yes, before the confidence interval, there's something you mentioned on coefficient something.
This was like that. We are saying you are comparing the p-value. You are comparing the p-value with this threshold of 0.05. Is that what you're asking? If I'm understanding you properly.
Yes, we had already compared the p, and then someone mentioned something about coefficient before we went to confidence interval. We were using the data from Stata. Yes, Apple.
Go ahead.
So there's something she mentioned on coefficient after us looking at the p-value being 0.484. And then you asked something to do with coefficient. So up I got lost. I didn't get what was mentioned.
You also can't remember. I can't remember. You know, we are talking too much. But I think what we are saying, I think if I remember, or we are going to try, is that we are saying we usually use the p-value for interpretation of our results, other than using the T and confidence interval. So the most commonly used test of our test is the p-value.
Yes.
Yeah, so I think that's what we meant.
Okay, thank you.
Any other question, comment? Good. So if there is none, I think we take like 15 minutes break. When we come back, we'll go back to the Excel, but now in this case, we add another variable. When we add another variable, we repeat the analysis now not manually, but in Stata, and see how to interpret now those results. I'm saying that because we are supposed to be focusing on multiple linear regression, not simple linear. But I thought it's wise we start with the simple, then you go to multiple, so that we don't. Is that okay?
Yes.
Okay.
Yes.
So we meet after 15 minutes, please. We meet at what? 1:16.
16.
1:17. 1:17. So that we can grab a cup of water.